Hello dear students, in this session we will try to derive equation for a torque acting on a rectangular current loop when it is placed in a uniform magnetic field. First we will consider a uniform magnetic field. Say this is a uniform magnetic field. In this uniform magnetic field, say we have considered one rectangular current loop. Rectangular current loop. Okay. I'll name this loop as P, Q, R and S. This is the rectangular current loop. Say the length of PS is L. Okay. Length of this rectangle is L. And breadth, let it be B. Length is L, breadth is B. Okay. Say the current is flowing like this. S, P, Q, R, S. Current is flowing like this. Now, since current carrying conductor is placed in a uniform magnetic field, okay, current carrying conductor experiences some force. What is that force? That force is given by the formula F is equal to F is equal to ILB sin theta. So what is theta? Theta is the angle between L and B. Okay. Now here, see, magnetic field is in this direction. Correct na? In this wire, current is going up. Then what is the direction of force? Direction of force on this PS is inwards. Direction of force is inwards. What about QR? Magnetic field is in this direction. Current is going downwards. So the force is outwards. So therefore, the force, magnetic force acting on PS and QR are in opposite direction. What about force on PQ and force on SR? Force on PQ, see, this is the direction of magnetic field. This is the direction of current. Force is upwards. Here, since the current direction is opposite, okay, since the current direction is opposite, force is downwards. See, force on PQ and force on SR, they are equal and opposite, they get cancelled. But what about force on PS and force on QR? Those two forces, okay, angle between, or the distance between those two forces is non-zero. Means there is a force and there is perpendicular distance between those two forces. So it constitutes a couple. Hope you can understand. So if there is a rod like this, okay, if one force is acting in this direction, the other force is acting in this direction, there is a torque. Why? Because line of action of force, there is a perpendicular distance between line of action of force. Okay. If there is an object and one force is acting in this direction, another force is acting in the opposite direction, now there is no torque. Why there is no torque? Because line of action of both the forces are same. Perpendicular distance between the forces, okay, is 0. So therefore there is no torque. But here what is happening? Here what is happening? So on PS the force is inwards, on QR the force is outwards. So the coil rotates like this. Okay. Now therefore magnetic force on PS or QR, that F is equal to ILB sin theta. Correct na? Magnetic force is equal to ILB sin theta. What is theta? Theta is the angle between L and B. So this is L, length of the conductor. Correct na? Where is magnetic field? Magnetic field is in this direction. Because, so what is magnetic force in vector form? Magnetic force is equal to I into L cross B. Where L is the length of the conductor. So theta is the angle between L and B. So therefore here L is in this direction, magnetic field is in this direction. Angle between them is 90 degree. Here also L is in this direction, magnetic field is in this direction. Angle is 90 degree. Sin 90 is 1. Okay, therefore F is equal to I L into B. Okay, now what is torque? Torque is equal to, okay, torque is equal to either force into perpendicular distance. Force into perpendicular distance. So what is the force? Force is equal to ILB. Force is equal to ILB. Okay, now what is the perpendicular distance Now what we'll do, so the coil is something like this, rectangular coil is something like this. We'll see the coil from the top. Okay, so then what happens? I can see only PQ. Now I can see P, Q, R and S. If I observe this from the top, I can see only P and Q. Correct now? I can see only P and Q. Okay. Now here at this point, what is the direction of magnetic field? This is the direction of magnetic field. Okay. Now you see, if the rectangular loop is like this, okay, then one force is in this direction, other force is in this direction, torque will be maximum because the perpendicular distance between the line of action of force is maximum. In this orientation, force on PS will be inwards, force on QR will be outwards. Those two forces are equal and opposite, they get cancelled. So the force, magnetic force on the coil, okay, on PS and QR, okay, or the torque, okay, torque depends on the orientation. So therefore, say for example, at some orientation, so this is the orientation, this is the direction of area vector, okay, this is the direction of area vector or magnetic moment. So what is magnetic moment? What is magnetic moment? I'll write here. Magnetic moment is equal to I into A. Magnetic moment is a vector quantity. Direction of magnetic moment is equal to direction of area vector. Okay. So therefore, if the coil is like this is the direction of magnetic moment. This is the direction of magnetic field. Let us suppose that angle between magnetic moment, okay, and magnetic field is theta. Then what happens? Then what is this length of PQ? Length of PQ is equal to B. Okay, length of PQ is what? B. B is the length. Why? Because see, the breadth is SR. SR equal to PQ. Now this, if this angle is theta, this angle is also equal to theta. Why? Because you see here, this B, okay, and this line, they are perpendicular to each other. Okay, and this M and this line, they are perpendicular to each other. So therefore, angle between these two lines should be equal to angle between these two lines. So this angle is therefore equal to theta. Therefore, perpendicular distance. See, on P the force is in this direction. On Q the force is in this direction. What is the perpendicular distance between the line of action of two forces? That is B sine theta. Because B is hypotenuse. For this theta, this is opposite side. So this will be B sine theta. So therefore, what is perpendicular distance? Perpendicular distance is B sine theta. Now what is L and B? L means length of the rectangle. B means breadth of the rectangle. Length into breadth will give you area. So tau is equal to IAB sine theta. Tau is equal to IAB sine theta. If there are n turns in the coil, if there are n turns, then what happens? Tau will be equal to NIAB into sine theta. Tau will be equal to NIAB sine theta. So what is magnetic moment? Magnetic moment is equal to I into A. If there are n turns, then magnetic moment is equal to N into I into A. Magnetic moment is equal to N into I into A. Therefore NIA can be replaced by magnetic moment M. I can write tau is equal to MB sine theta. Tau is equal to MB sine theta, or torque is equal to, in vector form, I can write it as M cross B. Torque is equal to M cross B. Torque is equal to M cross B. In electrostatics, you might have studied torque on an electric dipole. Tau is equal to P cross E. What is P? P means electric dipole moment. What is E? Electric field. Okay. Then this rectangular coil, okay, experiences a torque equal to M cross B. What is M? M means magnetic moment. B is magnetic field. So therefore, this is the torque on electric dipole. Okay. So therefore, this is the torque on magnetic dipole, or a rectangular loop placed in a uniform magnetic field behaves like a magnetic dipole. Hope you understood this. Thank you very much.